You know, audience, on today's episode of Pipeline Things, when's the last time you had a problem you just really nagged you, really struggled with? Today, we dive into the subject of CSCC and the challenges we're facing as an industry and maybe some of the solutions that are emerging on the market for that. And on the flip side, Chris tells us a little bit about his pool problems. So it's a good episode. We appreciate having our guest on. And again, if you're interested in Circumferential SCC, this is a good episode. Thanks for joining us. All right, that's a miss. We're going to keep it going. Welcome to today's episode of Pipeline Things. I am your host, Rhett Dotson. This is my co-host, Christopher DeLeon, and I will announce our guest shortly later. Chris, that was intentional because you can't be perfect in everything that you do. We can't always nail the clap every single episode or people think we stage it. And so every now and then you just have to miss one. Today was the one where we missed. That was staged, though.
Yeah, but sometimes you never know what you'll miss. So do you remember how I told you how lightning hit my pool?
So lightning is very close to my heart.
Yeah.
Yes.
Yeah.
That's the one where you spent digging for
it was a full day.
48 hours.
No, it wasn't 48
and
hours.
I called you and was like, why did you dig without me? I would have come to help you. And you're like up to your chest and it's like sandy clay. And
it's fantastic. Lots of pool water. Smells like chlorine. It was phenomenal. So obviously, the struggles with lightning, right? So obviously with your vehicle, you could never find the source of the problem, right? And you take it to somebody and they'd say, oh, that's not a problem, but really it kept coming back for you. So I'm having the same thing with the leak on my pool.
So get your audience up background. So for you guys that don't know, Christopher has a pool at his house. I have a pool at my house as well. Yeah. And Christopher's pool, it was a tree, right?
Yeah, so we hit lightning. It was the windstorm. We had this huge lightning strike and
hit the tree, but it hit the tree.
Yeah, and so we come outside and there is literally tree bark everywhere. Like it is incredible. I have probably literally like an 80-foot pine tree, and you just see this amazing like lightning strike on the side of the tree, and it was pretty impressive. Shortly after, the pool was draining like substantially. We were like, oh God.
Like losing water. Didn't you had dirt in your pool? All sorts of crazy stuff.
So the dirt was going backwards through the piping because obviously piping had ruptured. And so now the mud was kind of going back into the pool. So the pool turned brown within like 4 hours. It was just gross. And so obviously, instead of calling somebody,
you dug it up. You started at the pool pump and started digging towards the
find the leak. And about 15, 20 feet later.
25, 30.
Yep. I found the leak. And basically, one of the pipes had burst. It was pretty impressive. And it was adjacent to the tree at an interesting degree. So I guess I could have started digging there and maybe would have found it sooner. But point was, I don't know how much more damage there was. And
so you dug it up, replaced the pipe, the pool. I remember you got the pool back up and running.
And I was assuming everything was good. And then I started noticing that water was still leaking a little bit. And, on average, you own a pool in Texas, you lose water, every so many days. But I'm probably losing about an inch a day for a while. And that's a bit much. So I started investigating, started doing some online searching, talking to friends. They're like, hey, you need to check your skimmers. And I was like, hey, what do I check for? And they're like, sometimes the interface of the pool and the skimmer, the water will start eating out, eroding the interface. And so if you put your hand in there, you'll feel a dip. He goes, and that's basically where the water has kind of eroded some of the bonding material from the skimmer, the cement to the pool. So I checked, and by God, they were right. There's probably about 5 inches, pretty deep. I put a pin in there, and I was like, holy smokes, this is real. So I checked the other skimmer. Other skimmer was similar. And I was like, okay, maybe we are leaking water here. So I go to Home Depot and I buy this, wet drying cement, and I go in there and I drain the pool some and I put it in and fill the pool back up. And guess what? Pool's better for a while. I'm like, holy smokes, I finally fixed this. And this week, put more water in the pool, and here we are again. I'm losing about another inch of water a day. So I'm still searching for a leak. And I feel like this all happened at once because it wasn't leaking that bad.
And in the
before.
meantime, you're just learning a lot about your pool stuff.
So I don't know what the source of the leak is. I don't know what the source of the problem is, but I'm learning a whole lot about pool leaks right now.
So, audience, if you're out there, the real reason we did this is that Chris needs help digging up his yard, and Pipeline Things is soliciting for free labor for those of you who would like to help.
No, I know what's going to happen. Someone eventually would say, "Why don't you just call a professional to come and do a leak survey on your pool and tell you what's wrong?"
Already did that. You don't have a giant wet spot in your yard? You tried searching for that?
I have, and I don't have one. So obviously, when lightning hit the tree, there was a pretty substantial wet spot after about 4 to 6 hours.
So this is, honestly, you're in the let's just call it the CSI investigatory phase of trying to find out what is going on with your pool. Yeah. All you know is that you do have an issue and you have to work through it.
And learning a whole lot in the process. Like, I'm getting really good at this.
I didn't know this about skimmers. You taught me something.
Yeah.
That is actually a fantastic segue into today's guests. And in fact, the series that we're doing. So we are launching our mini series on circumferential SCC.
Yeah.
And so the genesis.
So why are we doing that again?
The genesis for that is that I feel like CSCC is the hot threat right now, to be honest. Like, I mean, I've been on the geohazards forefront for a while, and we've been talking about that in the industry for a while. But at IPC, it feels like everywhere I go, it started out with like, oh, there is a CSCC panel, or maybe there's a circumferential crack, group of papers, and they put 3 or 4 together. Now it's, there's 2 groups. Now there's a whole day. Yeah. And it feels like every conference you go to, whether it's PPIM or it's IPC, there are more papers in that category. There's more discussion around that. And there are more operators invested in that conversation. And so it feels like it's a very natural threat to take on in Pipeline Things. That's really what it feels like.
And it kind of fits in line with what we're trying to do, right? So we just wrapped up the IPC arc. Obviously, it was 2022, but it was in spirit of, we were preparing to be at IPC, and we just got back. And that was one of our big takeaways, right? We just felt like CSCC was one of those hot topics. So we figured we'd bring it to you guys. So here we are.
And so, again, in the spirit of learning and in the spirit of finding out what's going on out there, our first guest is none other than Jed Ludlow from TDW. That's who we're going to have one day to talk to us about what they're doing. And so, Miss Producer, when we do these virtual things, is he live now? Is he officially in the room? That's the way it works. See, there's no grand introduction. Jed, welcome to Pipeline Things.
Yeah, I don't get to pull up the chair.
I don't want to pull it. I mean, it's like, how do I introduce the guy? I don't know. It's like, I feel like I need to do a mock-up walk-on, do a little dance.
He pops up, pull out a chair, and have him pop up in the middle of us.
There we go.
Exactly. Yeah. No, thanks for the invitation. Great to be here.
Well, we'll see if you feel the same way by the end of the episode, Jed. That's always the key. Sure. Super excited to have you on. I will say, so catch the audience up on why we had Jed on. So obviously CSCC was a really big topic at IPC. Yeah. It's fair to say. And then shortly after IPC, there was a open house at the PRCI's TDC in
open
Houston.
House. Yep.
And you guys, TDW, presented some work that you guys are doing on this in the space of circumferential SCC. And Christopher just comes back gushing about it. And anytime Christopher comes back gushing about another speaker or another topic, I instantly get jealous because I'm only okay if Chris is gushing about me rather than gushing about other people. But it was you guys. And so that's what we have you guys here on to talk about. So really excited to hear what y'all are doing. But that's skipping a little too far ahead. I don't know if our audience knows you, Jed. So can you tell us a little bit about, go ahead and introduce yourself to the Pipeline Things audience.
Who is Jed and what should they know about you?
Yes.
Who am I? Good question. My route to the pipeline industry was probably a bit meandering compared with a lot of people. I started actually my career in the aerospace industry. So I worked mostly on accelerometer technologies, the kinds of instruments that go inside of IMUs. So in the pipeline world, we know all about IMU, right? I worked on.
Oh yeah, we don't need to talk about IMU here.
Yeah, I worked on the kinds of sensors that would go into an IMU, and so I have a very soft spot in my heart for inertial navigation. That's really kind of the first thing that got my that caught my real significant engineering interest, was this ability to navigate without but nothing more than sensors, right? And from there, it was a very large company. I felt like I wanted to spend a little bit more time in a small company. I jumped to a medical device manufacturer that was yet to be a manufacturer. It was a startup at the time, very small group of people. The kind of connecting thread between inertial sensors and that pump was this permanent magnets and multidisciplinary design. And the defining characteristic of that pump that we were working on, it was kind of artificial heart technology, is that it had a single moving part, a centrifugal pump, single moving part, completely suspended in a magnetic field. Okay, so permanent magnet design, a lot of multidisciplinary optimization questions were part of the design problem. And so that kind of continued this basic focus on systems that depended a lot on magnetics, mechanical, electrical, software things all rolled together. Well, funding on that particular project started to get pretty thin, and with a young family, I thought I got to get into something that's going to be a little bit more advanced and continue to push me forward. And in the valley where I live, Magpie Systems had been formed, and they'd just been recently acquired by TD Williamson. And Magpie was the predecessor, of course, to the ILI group here in TDW. And permanent magnets again brought me into the pipeline industry, right? And the fact that their inline inspection technologies are super multidisciplinary, right? There are mechanical, electrical, software, algorithms, all kinds of different problems to work, not just the pipeline aspect problems, but as an instrument designer, if you want to call it that, there are lots of important problems to continue to work on in the ILI space. And so that's kind
Yeah,
of
so
what brought
little
me to
did
the
you
pipeline
know.
industry.
Yeah, you were going to come full circle, Jed, because you started in
Exactly.
inertial navigation. You were going to work through the magnetic space, and then you just didn't know inertial navigation was going to become really a popular, hot topic again and drag you back into it, did you?
You're right. And in fact, it was one of the things that I thought was attractive about the pipeline industry was, hey, here's inertial navigation below ground. I'm happy to do it, right? So it was awesome. It's been a great opportunity to take advantage of some of those skills and that background to apply it to a pipeline setting instead of a, say, aircraft navigation setting.
And I'll let our little audience in on our secret. If you ever get a chance to run into Jed at a conference or see him, he's an absolute pleasure to talk to.
Yeah.
He's an engineer's engineer, right?
Yeah.
So if you want to dive into a technical or a nerdy conversation, that's your guy, 100%.
And again, I'm going to go back to Genesis of podcast, right? I mean, this is one of the things we want to do, right? So for all of our listeners, we want you guys, when you finish this episode, to feel like you know our guest. So do not hesitate. Jed might not know you, but you know him, so you need to close the loop. Next time you see him, go shake his hand and get to know him a little bit. He's a fun guy and he knows a whole lot. So don't hold back the questions.
That's
So,
really kind. Thanks.
so Jed, we brought you on to talk about circumferential SCC. And I think what I'd like you to do is just give you the space a little bit. Can you tell us what are you guys doing on that space? I mean, if an operator approaches you with the threat of circumferential SCC, what can you do?
Yeah, great question. And maybe to start with, the problem of circumferential SCC is not so much that it's always circumferential. It's that it's sometimes really disorganized cracking, right? And so usually when we're up against a cracking threat, most of the time the industry would turn towards an acoustic technique, right? That'll produce a reflection off these crack faces. We'll be able to find them. If you have a really disorderly cracking mechanism, particularly one that isn't necessarily perfectly circumferential or perfectly axially oriented, acoustic techniques become really challenging, right? And so the reflections that get created by these cracks go off in all different directions. They don't go back to their intended receiver, and so you lose them. And so what as circumferential or non-axial SCCs started to become more prevalent as operators that we work with have come across it, we have tried to work on, how with the technologies that exist in our existing portfolio of inspection techniques, how can we bring those to bear on a problem which traditionally would not be, a cracking problem traditionally would not be the kind of thing you'd go after with a magnetics technology, right?
Yeah.
I'll ask you, was that the first technique you would choose to go after cracking, right?
No, I think it's really interesting that you say that, Jeb, because I think I think it begs the question, how are we using magnetics for cracks? Again, I feel like 10 years ago, if you approached, any provider of MFL technology out there and asked them, hey, I've got a cracking problem.
Yeah.
And I'd like
Yeah.
you to put I mean, we've been saying for years, actually, I would argue we have been saying for years that you cannot or should not use magnetics for cracking. So I think it's definitely novel enough where, I mean, I must ask you, yeah.
Well, hold on. I want to jump in because I think one of the things that we should frame for the audience is the why we would traditionally had not gone towards a magnetic based tool for cracking. And by magnetics, I don't mean like an EMAT, right? Which is ultimately acoustic, right? What we're thinking here is it's
Purely
potentially magnetic from like a flux leakage perspective, yes. Right? And I think maybe 2 years ago I would have said, yeah, don't do it. Now I feel like I'd say, well, depends. It depends which ILI system you're considering. Because as we know, we've advocated a system is not just a sensoric technology, but it's also the evaluation procedures, your experience that manifests itself into algorithms. And so all of that is to say, because traditionally when we would talk about high resolution MFL tools, one of the things that we would struggle with is it's at the velocity, at the magnetic saturation, at the sensor resolution or spacing, is the aperture of whatever you're looking for sufficient to get flux leakage? And that's what we're looking for. And if the flux leakage isn't sufficient, then we struggle, right? Basically, it's a signal to noise ratio problem. And that's what we were struggling with. But now we're kind of in the age of what some would call ultra resolution tools where sensor spacings have gotten smaller. We kind of understand the response from flux leakage to magnetic saturation to all of these things to where I think we've learned enough about MFL technology and really the broader magnetics to say, are we only looking at flux leakage or are there other things in MFL data, not just the leakage, that can point us to what we might be looking for? And so now it's not maybe just cracks, it's rather it's crack-like. And so early manifestations that we've seen is I think one of y'all's terminology is it's axial planar, right? We know there's something here and it's not like your corrosion. And we found it this way. And we've heard fantastic feedback from our customers saying, hey, when TDW calls one of these, you need to understand what it is. And I feel like that was kind of like inroads towards, well, maybe magnetic technologies can help you find these crack-like indications, right?
Just for the record, I asked Jed the question.
It might not just be the flux leakage, right? But I'm setting the stage for you because ultimately it's your ILI system, right? And you're going to be able to shine light on it. Because you said, would you have thought about it? And I would say, I think there's enough evidence for me to maybe pause and not say no and say, maybe the right ILI system might be able to help.
Yeah. I think maybe a way to approach it is to, and not be super specific about any particular ILI implementation, but maybe talk about technically the kinds of things that are going on in the pipeline around circumferential SCC or non-axial presentation that might make it detectable, right, by a magnetic technique. But I would say that maybe you want to roll the clock all the way back to the late 1990s when Bruce Nesselroth published a big report coming out of Battelle that talked about the variation of magnetic properties in pipeline steels. He actually went and did a deep study on the impacts of stress on magnetic properties, the relationships, the correlations that exist between material strength properties and the magnetic properties of the steel. And the long and the short of it, without going too deep, is that at certain magnetization levels, the pipeline steel becomes, its permeability, its magnetic permeability becomes a function of stress, right? And so typically for like a high field magnetic flux leakage inspection, you're trying to push the field strength really high because you want to get away from those permeability variations. But if you're looking for something like stress in the line, at least localized stress, you might choose to magnetize to a lower level because then the localized stresses start to appear in a low magnetization. And so it's really that, there's kind of a perfect storm of threats that are happening around circumferential SCC. You've got, first of all, a susceptible material to start with. You've probably got a coating failure type that's creating a corrosive environment that presents the right chemical environment or environmental susceptibility, if you want to call it that. But then you've also got stress, right? The cracks are forming because there's stress, right? And that combination of things, from what we might call, let's say, a causal reasoning perspective, puts a magnetic technique like low field MFL in a good position to be a primary detector of locations of CSCC.
So is it fair to say, and Jed,
Yeah.
if you can't answer this, we'll edit it out, Miss Producer. Warning. So when you use, because I'm just asking, right? So we use high field and we look at the loss of flux by saturation.
Yeah.
Is what you're telling me that we're using low field in some semblance to localize stress, which we're then interpreting as cracks? Is that fair to say, what I'm hearing you say?
Yeah. Well, maybe I'll just rephrase that a tiny bit. We've known for a long time that localized stresses in the pipe wall can be located with a low strength magnetization. All of the work around mechanical damage that was produced over the past couple of decades, what you're really seeing there are permeability variations in the pipeline steel that manifest themselves when you magnetize to a certain low strength, right? And with circumferential SCC, there is a geometric presentation to the cracking, of course, right? And that's making a contribution to the kinds of things that we're seeing in the inline inspection data for sure, right? It's not just the crack alone is part of the response, right? But there is a stress response, particularly in the low field MFL, I think, which is a strong indicator of the confluence of all these things coming together and precipitating a circumferential crack to start to form. Okay, so it's really the combination of all these data sets coming together, which from a causal reasoning perspective gives you a strong argument to say, hey, this confluence of things are happening. The response you're getting here is likely crack related.
But the other data sets, how are you getting those, right? So you can't know whether or not there's a coding issue, I would assume, unless the operator tells you. Are you integrating other data sets, such as information you're getting from the operators that helps you in this type of threat assessment? I mean, because conventionally, right, you assess for like general metal loss or, depths or geometry. You guys assess it on your own, the ILI providers, right? But in this case, are you actually asking for information from the operators that you're then integrating into the assessment, or are you bringing in something in addition to low field MFL, or is it just low field alone?
Oh no, it's a combination of all the possible pieces of information we can bring together. And if a client knows about coding condition or the type of coding in place, that's certainly a risk factor. But quite honestly, if you've got tape wrap failure, that stuff is pretty easy to find in the patterns that it creates in MFL data for just even low level corrosion that's happening, even very low level. Those kinds of patterns are pretty easy to pick out. So in these prioritization models that we use to look for locations that are at higher risk, tape wrap coating failure is an indicator of places to look, right? If you've got that, you've got kind of a coating environment where shielding can be going on, where cathodic protection might be not helping you as much. You've got the sort of chemical environment where cracking can start to form. And so whether we have direct indication of the coating type or not, or whether it's failed, we can often see the telltale signs of it in the data.
Gotcha. So Jed, then I have to ask, how did you get drug into this? I mean, because conceivably, I'm thinking you guys didn't sit around a table and be like, you know what we should do?
I don't think they got drug into it.
We should. Well, no, but I mean, the point is, right? You shouldn't be like. I assume you weren't like, you know what we can do?
I got drug into digging up the pipe when my pool got struck by lightning. I don't think they got drug into figuring this out.
Well, I mean, but you made a decision. I mean, y'all are moving in a certain direction, which is to use a technology and the information you're getting from it in a manner that maybe we haven't conventionally done, right? And I mean, did you sit around a table and decide, you know what, let's go after circumferential cracks? Or did you start finding this problem? Because obviously you're describing to me there is a measurement principle that I don't want to dive too much into. But then you're also talking about characteristic signal patterns, other information you're getting from the operator. And I'm just curious how you guys found yourself using the technology that you had on board to solve a problem like CSCC. I mean, how did you get there?
Good question. I think, like most MFL technologies, or new applications of them, if I might say that, they grow out of usually a discovery process that is somewhat of a collaboration between the operator and the inline inspection provider. So we will maybe, let's say we've inspected a pipeline, they'll go out and evaluate some of the anomalies in the field, and they'll find something that's just completely surprising that no one expected to be there. And we'll kind of put that on the back burner and think about it for a while, and it will precipitate different kinds of thoughts about how what were we seeing there, right? Was there something there that might have that we weren't really accustomed to looking for, but might still be discernible in the data, right? So yeah, it's a very meandering discovery process, um, just like threats on the pipeline sort of get discovered gradually over time.
Mhm.
Uses of inline inspection technology can take a similar path, right? It's not like as soon as we produce a technology, it automatically has a spec. we we're very much in the process. One of my primary roles is to say, hey, what are new potential applications? What are we discovering new when we've inspected lines? And then what do we do with a technology which isn't 100% mature yet? How do we mature it to the point where eventually it can have a specification, right? And so I think it's really important for those kinds of discovery efforts to involve both the operator and the inline inspection provider on, on like a collaborative basis as opposed to a contractual basis, if you might want to call it that. You
And
can
I
learn
like
a
that.
lot.
and that's so fundamental, Jed, right? So obviously on many podcasts, you'll hear me be the first one to say, hey, if you don't understand the spec, why are you using a tool, right? But in a positive light of that, I think you're hitting on it, right? It's that idea of collaboration. It's when you have these multi-data set type tools, there's only so much you're going to learn through things like pool tests or in-house small scale testing.
Yeah.
These tools need to get vetted. They need to mature. And the only way for them to mature is through use and through, like you said, I love the way you said it. It's a process of discovery, right? So
Yeah.
as you're collaborating with operators and they're out in the ditch, seeing how the ILI system is responding to either feature types or certain materials or certain environments under certain different stresses or loads, that's when you start not necessarily maybe being able to develop a spec, because you're developing a spec in 1163, right? However, whether it's FEA or small scale testing, but now you're really understanding how you're able to refine it. And we've seen that with you guys, right? I feel like every time we get you guys on the podcast, you guys have discovered a new threat that you guys can solve and tie a spec to it. So
Yeah, I think just as the threat discovery process is a bit, I guess I won't say random, but it isn't well defined.
yeah.
The technology development process is also not always as cut and dried as one would hope, right? And so, as you said, the spec development process can be long. In the case of CSCC, the particular challenge is that really to be detectable, you kind of have to be in a stressed environment, right? So lab experiments are really
we are always stressed. Don't ever worry about that.
So,
right. Yeah.
Well, I tell you what, hey, Jed, we are actually going to take a quick break for our audience. And when we come back, I want to get into what you're finding, right? So obviously you guys are using this, and I'd love to hear what you're actually seeing in the field whenever we're digging up some of these signals and maybe some of the surprises that are there. So audience, hang on. We're going to be right back as we continue our conversation with Jed Ludlow on Circumferential SCC. All right, welcome back to Pipeline Things as we continue our conversation on Circumferential SCC with Jed Ludlow. So, Jed, I was reprimanded at the break by Chris, who said I wasn't asking you enough hard questions. So we're going to go into hard question mode.
Yeah. Right.
If you're ready, are you ready? Can you handle the hard questions?
You bet.
Okay, Jed, books or movies?
Audiobooks probably right now. Yeah.
Audiobooks.
Yeah.
Outdoors or indoors?
Oh man, tough questions indeed. These days it's a lot of indoors. Not that I like it that way, but I would prefer to be out a little bit more. But there's a lot of indoors with my current life. I'll just put it that way. Mostly indoors right now.
Would you rather fly or drive?
Oh, fly. I love flying.
Ooh. All right. Monopoly or Uno?
Monopoly just takes forever. Uno.
Uno brings out conflict, and that's what makes games fun, right?
Well,
landing on boardwalk is not the same as giving somebody a draw 4.
Yeah,
those are not the same.
I'm often playing with like groups of youth, and then they have their own, like off design rules or house rules, and that always makes it really crazy.
I hate house rules. You should play Uno according to the rules. And when they
indeed,
like I played with a group the other day that you could lay a draw 2 on top of a draw 2, and then it became a draw 4.
Stacking.
And I was like, that's not a rule.
It's called stacking.
It almost drew blood. Most important one of the day: Apple or Android?
Oh, Android all the way.
Oh, come on! Miss Producer, you got to edit that out. That's getting out of here.
Jed,
Let's
you
go.
are now my favorite guest. Fantastic. That's how you know. You know you got a true nerd whenever
We're
you get an
gonna have to start
Android.
filtering people out based
100%.
on that preference.
My phone is not rooted, though. I will say that I'm not rooted Android.
All that,
Just
all
stock
that is
Android.
a green bubble machine. That's all that is. Green bubble machine.
Yeah, right.
All right. So I told you those are the most difficult questions. All right. So Jed, going back to our conversation.
Yeah.
Good fun. So I want to get into the subject of what you guys are learning now, right? And so I might a little bit seed it. One of the things I feel like that is shifting in this circumferential SCC conversation is early on, a lot of people were trying to use bending strain. And they approached me with that subject. And I'm like, well, I could see where you would use it, but there's some challenges in directly applying bending strain. But I still see bending strain appearing in a lot of the threat prioritization schemas that I see proposed for circumferential SCC. And then even this year, Doug Dewar did a great presentation in his paper where he talked about the fact of like, look, of all, I think it was like 135 circumferential SCC features they dug. Very few of them, very few were associated with any type of geohazard or associated bending strain feature at all.
Yeah.
And I'm curious on that front, are you guys having similar experiences that you can share about? Does or bending strain fit at all within the priority scheme? And maybe what types of things are you guys learning on the CSCC front?
Yeah, it's an excellent question. So maybe I'll say that we do consider for sure bending strain and geohazard sources as a risk elevation, right? Certainly if you've got those kinds of features, they are sources of stress, right? They can be, right? So you shouldn't ignore them. And they should be areas that get looked at. And we have routinely used them as elevated locations of elevated interest in the risk prioritization. But what we're finding more and more frequently is commensurate with what was presented at IPC, that certainly is not the only place and shouldn't even be the primary place that you go looking for cracking. Because it turns out, and I don't think anyone really has a great answer for this yet, but there is axial stress present in a lot of locations up and down the pipeline. And whether that's come from ground motion or whether that was there built in from the outset at construction time, it's not 100% clear. So I think the most surprising fact is we will find CSCC in straight pipe, right? We'll find it in locations where there isn't necessarily a bending strain feature.
So what do you mean by straight pipe? Are you saying that it's just not a bending strain feature?
Yeah.
Are you saying straight pipe like I'm in a farmer's field and it's just straight as long as the eye can see? I mean, what does straight pipe mean?
Straight pipe meaning if you're only looking for bending strains, you may not be looking at all the important locations. And that's a relatively new discovery, I think, across the industry, is that we're finding CSCC in more locations than we had expected to find these features. And maybe the open question is, what is the source of stress? Clearly, there's got to be some stress for the cracks to be forming in the first place, right? But I think it's the fact that there is more distributed axial stress out there than we had imagined, perhaps.
So on that thought of bending strain, Jed, I'm curious, have you guys looked at using it at all? Not like, so a lot of people, when we look for bending strain, we're looking for features that are above a reporting threshold, which is typically in the plastic zone. And in SCC in general, usually needs like an elastic stress field, 60 to 100% of SMICE in order for cracks to form, not plasticity beyond that.
Yeah.
Have you guys looked at using bending strain in a non-conventional sense at all, where you're not, and this is what I've approached people about, like, look, if you're thinking that, oh, my 0.3% geohazard feature is more critical than my, low level 0.1% feature in a crossing, I was like, that's a misunderstanding of potentially how you might use it, because that 0.3 is heavily plastic. That's a different animal. Whereas this over here just might have a decent amount of residual construction from like roping or putting the pipe in the ground, trying to make a crossing. Are you guys looking at using bending strain in any sort of novel way? Or can you share that at all?
Yeah, I don't know if I have a lot to add on the particulars of like crazy uses of the bending strain. I would say that maybe a more direct approach is to say that certainly bending strain and ground movement features cause stress in the line, right? Cause large distributed stresses, right? I would say that we are probably more focused today on how do I detect the local elevated stress field that's happening around the crack, And that's probably, we think, a more fruitful way to get at the real location of where all these are presenting themselves, is that in order for the crack to have formed in the first place, there's got to be some stress field that's creating that environment for the crack to form. And so, can we do something to try to find that directly? And most of our more recent efforts are along the lines of how do I do that, right? So I
Gotcha.
maybe in short, there probably are some more creative uses to bending strain. I don't know that we've got all the correlation information to know how to do that yet. But we will say that I think localized stresses using something like a magnetic technique, or even an electromagnetic technique for that matter, are going to be good at finding localized elevated stresses.
So you finding it in places you don't expect.
Yeah,
Are you also, I think it's a fair question to ask, are you also finding it in places you do expect?
sure, certainly.
Right? Are you
Yeah.
finding it like in bends or
You mean field bends or
yeah,
deliberate
yeah,
bends?
we know I guess we could throw fittings too. Yeah, I mean cold bends or fittings, or is there any differentiation there?
I'm not sure if I have enough there to make a definitive statement about it. Certainly, we have found it in things that would be conventionally called a geohazard, right?
Hmm.
Areas
Okay.
where landsliding has happened, we have found these kinds of features, right? So again, it's not that you shouldn't ignore those. They are, in fact, areas of elevated risk, but they're not the only places you need to be looking for it. And getting after a more
And Jed,
primary detector is a good route. So
and I want to echo that, right? I mean, I think that's the takeaway, right? Is that, we're finding what I'm going to call off-axis cracking, right? Meaning non-axial, where there's some envelope or some window of what we're defining as axial cracking, right? Call it 10 degrees or 15 degrees off-axis.
If it's perpendicular, isn't that on a different axis?
Yeah, that's what I'm saying. It's off-axis.
But it's on its own
Oh,
axis.
okay, well,
Right?
then circumferential. So circumferential and off-axis, right? So everything in between. But I think the point was that, I mean, there has been success in leveraging bending strain data in certain ILI indications, and cracking has been found, right? And I feel like that was kind of like a baseline where we were trying to use diagnostic technology like ILI with a numerical analysis like bending strain to try to identify where these threats can be found, right? This threat of circumferential or off-axis cracking. And it's actually more recent that we're starting to discover that there is additional cracking that is not necessarily related to these bending strain features, right? These external loads from in that regard. So it's not just that we're moving away from traditionally what things have had the way we've done things, but rather it's an augmentation of, right?
yep.
And the way we were detecting or diagnosing that we have a crack-like feature is just changing, right? So we have one technique for one type of cracking, and now we're discovering that there's additional cracking, and the mechanism by which we detect them and identify them and report them, it's a different approach. Is the way I'm wanting to describe it. Would you agree?
Yeah. I think you go back to the sort of causal reasoning behind why the cracks are in the first place, and it helps you just say, well, okay, these are showing up in places where causally we didn't think they should, right? What more can we do to augment? What additional tools, technologies do we have at our disposal to throw at the problem to modify the causal argument around why we should be able to see these? And that's kind of where we're focusing right now, is to say, hey, with the magnetic techniques at our disposal, is there a causal argument to be made? And we feel like there is actually a pretty strong one.
So Jed, where do you think we go from here in 2025, 2026?
Yeah.
Where do we as an industry need to focus efforts to tackle this problem? What does it look like?
Yeah, I think it's a continued collaboration. I think it's a continued process of allowing both the technology to evolve and improve, along with a discovery of what is really causing these things in the field, and where can we identify additional patterns about where they're starting to show up. Are they localized to certain areas on the pipeline from, let's say, a tie-ins perspective, or are there other things that we can develop that help strengthen the correlation and get us more at the causal mechanisms? But I would say that that journey can be tortuous and a little bit long. It does
Yeah.
require digging things up that are things you might not
Miss us.
expect to really be a feature of interest, right?
Yeah.
And it does require getting at crack depths in a super reliable way is not always easy, right? And non-destructive evaluation techniques will get you so far, but sometimes they don't capture the complete severity of a feature. So there is a decent amount of sometimes having to go all the way to metallurgy to figure out what's really going on. So
yeah, and being a little bit tolerant, right,
yeah,
with the level of maturity for a specific threat, right? I mean, maybe round one is we're detecting it, but maybe if it just turns out that it's voluminous enough to where we can't risk rank them yet, or offer you a particular depth. I mean, that's maybe something as an industry we got to get comfortable with and say, hey, first, we got to understand that we can reliably detect them and we can identify them, right? And then in time, with the right feedback loop and continued investment on y'all's behalf and operators and everybody understanding how to improve it, then potentially the sizing component of it.
yeah. And I think there is really good progress already demonstrated in the industry towards being able to put a depth on these to some extent, right?
Yeah.
Exactly how good that depth is today, we're not 100% sure, but there really is good progress towards, I think, that direction. But again, it's just going to take some time, some patience, and what I would say is early stage technology development and collaboration with operators. That's kind of the mode we're still in.
Fantastic. Well, Jed, I want to say thank you for joining us and setting the stage for the Circumferential SCC conversation. So hopefully we'll be seeing you around at the future in either PPIM or IPC and having more discussions with you about this. Look forward to continuing that.
Absolutely.
Any parting words?
Thanks for the invite. Great to be able to be a part of your podcast, and tough questions, yes, but very fair.
Hopefully, hopefully I think the metric of success is if your phone starts ringing or your inbox start getting full and there's much harder questions.
Yep.
Because that means you're able to help them.
Keep that Android phone ringing. So on that note, I want to say thanks for joining us. And to our audience, we look forward to continuing this conversation on Circumferential SCC. Thank you for joining us on this edition of Pipeline Things, and we'll see you again in 2 weeks. This episode of Pipeline Things was sponsored by D2 Integrity. Executive producer Sarah Etier. Filming was done at the Work Lodge, and we'd like to thank our guest, Jed Ludlow from TD Williamson. Thank you.